So in class today, we talked about a permutation test and how it works. And it seemed like some of you were still a little confused at the end of class, and so I wanted to give another example to hopefully illustrate why, in fact, the permutation test works. So I'm going to set my seed in R here so that we can get the same results, that we get the reproducible example. And what I'm going to do here is I'm going to start off by generating a predictor variable using a sample from a normal distribution. There's nothing special about this predictor, it's just a predictor. And now I'm also going to create a response variable y that has a clear linear relationship with the predictor x. So the intercept is 1, the slope is 3, and then I'm also going to add a little bit of error to my response here. And if I plot y versus x, you see a clear example of a linear relationship. So y and x are definitely related. X is important in predicting the response y. So in a permutation test, we know that we're going to permute the response and compare that to our predictor. And so let's just look at what would happen if we permuted our response and then plotted the results against x. And you can see we have a very different pattern from what we saw before. And so when I permute the response, and there is a relationship between y and x, it destroys the relationship that we would otherwise see. And the same sort of pattern happens when we do our permutation test. So what I'm going to do here is I'm going to calculate the observed F statistic, testing whether there's a relationship between the response and the predictor. And so I'm going to fit that model, I'm going to summarize the model, and then I'm going to extract the F statistic from the fitted model. So F obs is the F statistic for my observed data set, and the value, the test statistic is 509. So that's actually a very large test statistic for a data set of this size. So this would be considered extreme or strong evidence in the general sense. But we have to do our hypothesis test to confirm this. So now I'm going to actually go through the process of permuting the response, fitting the permuted response on the predictor variable, summarizing the result, and extracting the F statistic. So specifically, I permute the response here, and then I fit a linear model with the permuted response on the predictor variable x. Then I summarize the model fit, and lastly I extract the F statistic from the model fit of the permuted data. And then I'm going to store it for later use because I want to look at that. So I'm going to do that 4,000 times. And now I have 4,000 test statistics from the permuted data sets. And I'm just going to look at the distribution of the simulated F statistics. Okay, so we see that something that actually looks similar to an F distribution. It's a positively skewed distribution, extends out here to about 40 or so. So that's the distribution of my simulated test statistics, or that's another way of just saying the test statistics for the permuted data sets. And now what I want to do is I want to compare the observed test statistic to the distribution of the simulated test statistics. So I'm going to plot the same distribution, but I'm going to make sure that I extend the x-axis far enough to show the observed response, the observed test statistic as well. So even though this plot looks very different, in fact this curve is the exact same curve as we see here. It's just that we've extended the x-axis to well over 500. And now I'm also going to plot the observed test statistic on this graph, and we can see that the observed test statistic is way over here. The test statistics from the simulated data sets are way over here. And this is exactly what we expect to see if there is, in fact, a relationship between the response and predictor. And we use a permutation to test whether there is no relationship. So if there is a relationship, then we expect that the observed test statistic will be extreme in comparison with the test statistic from the permuted data sets. And in fact, the p-value for this test was 0, which means that not a single test statistic from the permuted data sets was as large as the observed test statistic. So this is very strong evidence of a relationship between the response and the predictor. Now let's look at what happens when there in fact is no relationship between the response and the predictor. So I'm going to generate a new data set, but in this data set there's no x variable, so there's no relationship between the response and the predictor. And if I plot this new data set, okay, we can see that there's no clear pattern, there's no evidence of a relationship between y and x. And what would happen if I permuted the response and then plotted the permuted response against the predictor? Well, I see something sort of similar to what we saw before. We just see a random scatter of points in the vertical direction as I move along the x-axis. So this plot doesn't look very different from the plot of the original data. Now we're going to conduct another permutation test. So I'm going to regress the response on x, even though there's actually no relationship between them. I'm going to fit that model, I'm going to summarize the results, and I'm going to extract the F statistic for later use. And I'm going to do the same thing for my permuted response. So I'm going to do the same thing I did before, where I permute the response, I fit the linear model with a permuted response, I summarize the results, and then I extract the F statistic from that model. And now that I've fit those, I'm going to once again plot the distribution of my simulated test statistics. And I want to compare them to the distribution of the observed test statistic. I shouldn't say the distribution, but I want to compare them to the value of the observed test statistic. So if there is no relationship between the response and predictor, and I use a permutation test, then what I expect to see is the observed test statistic falling somewhere within the middle of the distribution of my simulated test statistics. So this line right here represents the distribution of my simulated test statistics. And then this vertical line right here is the observed test statistic. And you can see that it falls very much in the center, well, maybe not the center, but nowhere near it's not at the extreme ends, it's not way up here in comparison with my simulated distribution. And so if I compute the p-value for this test, it's 0.82. There's no evidence of a linear relationship between the response and the predictor variable in this case. So just to summarize, if there is a relationship between the response and our predictor variables, and we do this permuted F test, then we would see that the observed test statistic would be very extreme, very unusual in comparison with the test statistics from the simulated data sets. But if there is not a relationship between the response and the predictor, then the observed test statistic will just fall somewhere closer to the middle of my test statistics for the simulated data.